Today we're doing 10-3. It's called Analyzing Functions Graphically. So it's kind of going to be a little bit of a review from everything we've learned how to graph from the entire year. The only thing that's going to be really new to you is end behavior. We haven't talked about end behavior, but the rest of it should just kind of be review. Kind of an odd section, but I think it's not a bad idea to do it just because it's going to review everything from the year. All right. When we started off the year, we learned how to graph linear functions. So for example, a linear function, it's a line. F of x equals 2x plus 1, that's a linear function. When you graph it, you're first going to start off with graphing the y-intercept, and then you'll graph the slope. So the y-intercept is 1, so we'll go up to 1, and the slope is 2, so we'll go up 2 over 1, up 2 over 1, up 2 over 1, same thing in the opposite direction, down 2 over 1 this way, and you can connect the dots. Okay, so what is the domain? So what are all of your possible x values? Well, your x values are going on forever this way, right? Slowly but surely, they're just going to keep going on that way, and they're going to keep going on this way. So it's all real numbers for the domain, where you could say all reals, or you could say negative infinity to positive infinity. Your range is the same thing. Your range, your y values, they're just going to keep going up and up and up. There's no stop to it, and your y values are just going to keep going down, down, down. So all real numbers. Axis of symmetry. Your axis of symmetry is the line that divides the function in half. For a line, there is no axis of symmetry. I can't draw a line down this and divide it in half. It wouldn't reflect onto each other like it will with some other functions. So there's no axis of symmetry, so you could say no axis of symmetry. That's how I abbreviate axis of symmetry, AOS. Minimum or maximum value. There is no lowest point on this graph, and there's no highest point on this graph since it keeps going on forever in both directions, so there's none for that. No min, no max. End behavior. This is how you write end behavior every single time. You want to write as x approaches infinity, y approaches. So as x approaches, this arrow means approaches, and then that's the infinity sign. So if I'm going this way on my graph, right, if x is approaching in positive infinity, that means I'm going to go this way. What's happening to my y values? My y values are going up. When I'm going this way on my graph, my y values are going up. So y approaches positive infinity. Then we have to write as x approaches negative infinity, what's happening with y. So now as we're going this way on the graph, our y values are going down, okay? If I'm heading this way on the graph, my y values are going down. So y is approaching negative infinity. That's always how you set up your end behavior. This is a concept you're going to delve deeper into in Algebra 2. In Algebra 1, you really should just get a little introduction of it, which is what I'm giving you right now. It's a more of a higher level concept. So if it's confusing to you, it's not really a huge deal right now. It's because you're just getting an introduction of it. Okay, how to graph an absolute value function. So absolute value functions, remember, those are our V-shapes. The pattern is up one, right one, up one, left one. So you start at your origin, you go up 1 over 1, up 1 over 1, up 1 over 1, and you do the same thing on the opposite side, and it makes a V shape. Now remember, this pattern only works when A is 1, when you have 1 in front of here. If you had like a 2 in front of here, it would change the pattern. Okay, the domain. Your domain is all of the x values in both directions, okay? So that would be all real numbers. Your range, your y values, there's no y values down here. There's no negative y values. Your y values are greater than or equal to 0 because your y values start at 0 and they go up. So y is greater than or equal to 0. Your axis of symmetry. For this graph, we do have an axis of symmetry. It's the imaginary line that cuts the graph in half. And that is the line x equals 0. It's a vertical line, x equals 0. Okay, that's where it is. Minimum or maximum value. We do have a minimum value here. We have a lowest point, no maximum value. We have a minimum at 0, 0. Okay, now end behavior. As x approaches positive infinity, so as we're heading this way on the graph, what's happening to your y values? Your y values are going up. So y approaches positive infinity. Then we have to go the opposite way. As x approaches negative infinity, so as we go this way on the graph, okay, as x is approaching negative infinity, what's happening to your y values? Your y values are going up. So y approaches positive infinity. Okay, next. Here's another absolute value function. So for this, this is an absolute value function moved up 2 units. So we just go up 2, and then we do our pattern, up 1 over 1, up 1 over 1. Same thing in both directions. Okay. Your domain is all of the x values. It goes on forever in this direction and this direction. So all of the x values are included. So all real numbers. Your range, well, your lowest y value is 2, and then it goes up from there. So it's y is greater than or equal to 2. Your axis of symmetry, same thing as before, x equals 0. That's the imaginary line that cuts this graph in half. Your minimum or maximum value, we have a minimum value, no maximum value. We have a lowest value at 0, 2. And then end behavior, it's going to be the same thing as the last one. As x approaches infinity, so if I'm going this way on the graph, that means your y values are going up, so y approaches infinity. And then as x approaches negative infinity, so if I'm going this way on the graph, my y values go up. Y approaches positive infinity. Okay. Example 3, how to graph a quadratic. So quadratic functions, that's our parabola. So the pattern is up 1, right 1, up 1, left 1, up 3, right 1, up 3, left 1. Now remember, that's only for if the a is 1. If a is 2, it's going to be a different pattern. It's not going to follow that same pattern. But we don't have to worry about that because we're just going over the basics. Okay, so we have our first point at 0, 0, up 1 over 1, up 1, 2, 3 over 1, and then it'll go up 5 over 1. You can graph that if you want. You don't have to. Like that. And it makes that U shape, which we've talked about with throwing a ball, fountains, all different kinds of examples we talked about. The arch we talked about in architecture. Okay, your domain. So all possible x values are included on this graph because your x values are just going to keep going this way. You're going to keep having more x values that go this way, and you're going to have x values that go this way on forever. So all real numbers. Your range, your lowest y value is 0, and then the values just go up from there. So y is greater than or equal to 0. Your axis of symmetry, the imaginary line that splits this graph in half, is x equals 0. You have a minimum value at 0, 0. And end behavior. So as x approaches infinity, so if I'm going this way on my graph, my y values are going up. Y approaches infinity. And then as x approaches negative infinity, as x approaches negative infinity, my y values are also approaching positive infinity. Okay, next, another quadratic function. This parabola is moved 3 units down. Okay, so for this one, we're going to go 3 units down. Then we're going to go up 1 over 1, up 1, 2, 3 over 1. You can go up 5 over 1 if you want. 1, 2, 3 over 1, and it makes that U shape. Your domain, all real numbers again. Your range, your lowest y value is -3, and then it's up from there, so y is greater than or equal to -3. Your axis of symmetry is still x equals 0. You have a minimum value for this at 0, -3. That's your lowest value. And end behavior as x approaches infinity. So if I'm going this way on the graph, my y values go up, so y approaches infinity. And then as x approaches -infinity, my y values are going up. Okay, how to graph an exponential. Exponential functions, we don't really have a pattern for that. There is no pattern. We have to make a table for this. We learned this kind of a while ago, so let's just review. So for this, I like to pick these values, -2, -1, 0, 1, 2. So if we plug in -2, that would be 2 to the -2. Remember, negative exponent rule means move it to the bottom. So now this is 1 over 2 squared. When you move it to the bottom, it becomes positive. So that's 1/4. For this one, 2 to the -1 is 1 over 2 to the first power, right? The 1 becomes positive. So that's 1/2. For this one, 2 to the 0 power, anything to the 0 power is 1. 2 to the first power is 2, and then 2 to the second power, or 2 squared, is 4. So now we can graph these. -2, 1/4 is right about here. -1, 1/2 is a tiny bit higher. You're not really going to see it very well in your graph, but it is a little bit higher. 0, 1 is right here. 1, 2, 2, 4. So this is what the graph looks like. It's important that when you draw your arrow on this side, you do not let it cross this x-axis here, because it's not crossing the x-axis. We talked about this in class. It's a little confusing, but any value you put in here, so you can plug in -3, you can plug in -4, you can plug in -5. It's just going to keep getting closer to 0, but it's never going to cross this x-axis. This is the asymptote. You might remember that from class. So let's talk about our domain. So our domain is still all real numbers. You can have any x values this way and any x values that way. All real numbers. For your range, y is greater than 0, okay? It's not equal to 0 because it's approaching 0, but it's never going to touch 0. It's never going to touch this x-axis here. It's going to get closer and closer and closer to 0, and then it's just going to keep going up. Axis of symmetry, there is none. There's no line that you can put that'll, whatchamacallit, there's no like line of reflection there. Maximum or minimum value, there is none. And behavior, as x approaches positive infinity, y approaches, so if I'm going this way on my graph, as x is approaching positive infinity, my y values are going up. So y approaches positive infinity. As x approaches negative infinity, my y values are approaching not negative infinity, they're actually approaching 0 because they're not going to cross that x-axis. So my y values are approaching 0. Okay, square root function. Square root function. Okay, so for this one, when I taught square root function and when I taught cube root function, I was teaching with tables and I was noticing you guys are super confused. So we're not going to do tables, we're just going to use the pattern. The pattern for graphing a square root function is up 1, right 1, up 1, right 3. So start at 0, 0, go up 1, right 1, then go up 1, right 1, 2, 3, and it makes like half of a parabola sideways. The domain, so all of your x values, it's not negative infinity to positive infinity, it's not all real numbers. It's going to be your x value is your smallest, x value is 0, and then they're going that way. So it's x is greater than or equal to 0. Your range is also y is greater than or equal to 0 because your smallest y value is 0, and then they go up. Your axis of symmetry is none, or you could write no axis of symmetry. Minimum or maximum value, we do have a minimum value here at 0, 0. That's our lowest value. And behavior as x, oops. As x approaches infinity, y approaches, so if I'm going this way on my graph, my y values are going up, so y approaches infinity. And then instead of saying as x approaches negative infinity, we're going to say as x approaches 0, because it's really not approaching negative infinity, it's approaching 0. So as x approaches 0, your y values also approach 0. You really don't need this one that much. This is really what's important, this first one. Okay, next, another square root function. This square root function is shifted 2 units to the right. You can tell by our shift. Whatever is under the radical, you do the opposite of that. So it's shifted 2 units to the right. So we're going to go 2 units to the right. Then we're going to follow our pattern, up 1 over 1, and then up 1 over 1, 2, 3. So it looks like that. Your domain is x is greater than or equal to 2, and your y is greater than or equal to 0. Sorry, your domain is x is greater than or equal to 2. Your smallest x value is 2, and then it goes that way. And then your range is y is greater than or equal to 0, because your smallest y value is 0, and then it just keeps going up. Axis of symmetry, there is none. You do have a min value here at 2, 0. And end behavior, as x approaches infinity, y approaches infinity, and then as x approaches 0, y approaches 0. Same thing as the last one. Okay, last problem. Hanging in there. All right, how to graph a cube root function. So cube root function, your pattern is up 1, right 1, up 1, right 7, and then you go back to the origin, then you go down 1, left 1, down 1, left 7. So we're starting at 0, 0, up 1, right 1, up 1, right 1, 2, 3, 4, 5, 6, 7. Then you go back to your origin, down 1, left 1, down 1, left 1, 2, 3, 4, 5, 6, 7. And it makes like a, kind of like an S shape. Okay. Your domain. So your domain is all real numbers. Your x values go on forever in this direction and that direction. Same thing with your y values. They're just going to keep going up and up and up and down and down, down. So all real numbers for your range. Your axis of symmetry, there is none. You might think we could split the graph in half here, but if you reflected it over, it's not going to match on top of this part. You have no minimum or maximum values. And then for your end behavior, as x approaches infinity, y approaches infinity. So if I'm going this way on my graph, my y values are going up. If I'm going this way on my graph, my y values are going down. So as x approaches negative infinity, y approaches negative infinity. Okay, your homework. It doesn't say you have to graph all of them. However, you kind of do to be able to tell what like the domain and range are, the end behavior. You kind of have to graph all of them. You can use your graphing calculator instead. I'm not going to expect you to write all those graphs out. And then I also posted an emulator for you if you do not have a graphing calculator at home. So please download that. All right, thanks for sticking with me. I know it was a long one. Have a great day.